Dear all, welcome to the playlist of Training on Competitive Examination. So I'll be discussing a few questions from network analysis. This will be helpful for electronics and communication, electrical and electronics engineering, then electronics and instrumentation students, basically electrical streams. Okay. So first of all, you can able to go through the 5 important questions and I request you to mark the right answer. So let me show you the questions. Before solving, you can go through the basics of Kirchhoff voltage law and Kirchhoff current law, then star delta connection and its transformation, how to convert star into delta and vice versa. And you need to have a basic knowledge on periodic signals. What do you mean by periodic signal? What's the time period? Some basic information is required. So then you can go to the basics of the second order control system. Okay. So these are the prerequisites to solve those 5 questions. You can go through the particular questions and the answer is given below. Identify the right answer. And question 2, you can able to find out the correct answer. If you want, you can pause the video and don't take more than 1 minute. And question number 3, if you want, you can draw the necessary diagrams. That is up to you, but we require the final answer. It should be correct. And question number 4, you can able to identify the right answer. Question number 5, you can find out the right answer and kindly note down. Okay. So let me show you the questions in the descending order. Hope you have noted down the correct answer. If you have noted, let us discuss the question one by one. Is it okay? Yeah. Let me discuss the question number 1 to 5 respectively. Moving on to the discussion. Please go through the first question. Consider the network shown below with R1 that is equal to 1 ohm, R2 is equal to 2 ohm, R3 is equal to 3 ohm. The network is connected to a constant voltage source of 11 volt. That is also given. The magnitude of current in ampere, at least you have to go ahead with the 2 decimal places, through the source is dash. What is the total current flowing through the circuit? That I have to calculate it. I need to recall the concept of KVL. Okay, you need to know KVL, then KCL, and also I need to know the Ohm's law. What is Ohm's law? So if you know these concepts, you can easily compute the particular question. And also you need to know what is the potential difference. Okay, these concepts you have to recall right now. Okay, now let us solve this. First of all, you can draw the same circuit diagram once again. So let me draw the same circuit diagram. Later, what you're supposed to do is, so kindly note down the nodes, wherever the nodes are available. This is first node A, and the second one is node B, then node C, and node D. You have to mark these kind of nodes. And you know that the potential at node A is equal to potential at node B. So I'll be writing in this manner. In the same way, the potential at the node C is equal to potential at node D. It is very true. Now, if both the potentials are equal means there is no current flow. There won't be any current flow between A and B. Okay, so can I able to ignore the resistor R2 and this R2? Is it possible? Okay, in spite of making resistor, I can able to make a single branch. Yes, it is possible, right? Just think over that. Yeah, let me modify the diagram. Hope you are understanding. If you are having any confusion, please put up in the comment box. I'll be sharing my mail ID also. You can able to communicate with me. Definitely, I'll help you out. The thing is, in spite of drawing the resistor, I'll be putting only a single branch, AB and CD. Single line I'll be making out. Or else what I can do is, just modify it because R1 and R2 both are parallel. So can I able to draw in this manner? It is very correct, no? And also R1, R1, then R3, R3. So I'll be making in this way. Hope you are comfortable. And in the third cases, I can write in this manner. Now you have to recall the value. What is R1? R1 is equal to 1 ohm. So mark accordingly. R1, 1 ohm. So like this. R3 means how much? 3 ohm. So please mark accordingly so that you can able to solve it very quickly. So don't take more time because time matters a lot. So R1 is equal to 1 ohm only. So mark it properly. Then I think you can solve it very fastly. 1 ohm. See, you know the concept of two resistors are in parallel. So R equivalent is equal to, how we can able to make R1 R2 by R1 R2 by R1 plus R2. R1 plus R2. Apply quickly. Okay, this is a shortcut. So here you can able to segment these two branches together. So R1 into R1 by R1 plus R1 plus R1. Here R3 into R3 by then R3 plus R3. Finally, these two branches along you can make out a single two branches. Again, you can able to further simplify. And then first of all, you have to calculate R equivalent. R equivalent. You calculate R equivalent. Okay. So first of all, you have to calculate R equivalent. Anyway, I know the voltage. Voltage is 11 volt. Any applying the Ohm's law, V is equal to IR. Therefore, current I need to calculate. I is equal to V upon R or V by R. V by R equivalent. Let me write just R equivalent. So let me show you the answer so that you will understand. This is a shortcut method. So please solve it quickly and I'll be showing you the answer. What could be the right answer? So let me show you the particular answer so that you can able to verify it quickly. Yes. See, R equivalent I am getting. I am able to get R equivalent is equal to 11 by 8 ohm. And the voltage is given as 11 volt. So I is equal to V by R equivalent. V by R equivalent. So voltage is how much? Of course, it's 11 divided by the R equivalent is equal to 11 by 8. 11 by 8. If you solve, you can apply, you can multiply with the reciprocals. So how much it will be? 11 into 8 by 11. 8 by 11. So 11 and 11 get cancelled. So the total current which is flowing through the particular circuit is equal to 8 ampere. Of course, the right answer is 8 ampere. So which option should I choose? I need to choose the 8 ampere. So check whether it is available in the option or not. That's very important. Okay, because these are the multiple choice questions. Answers are very important rather than doing the steps. Answers and time, accuracy, everything matters a lot. So which is the right answer? Of course, I have to go ahead with the option B. Hope you are okay. If you are having any issues, kindly put up in the comment box. Any other issues are there while solving, you can put up. Don't take more than 1 minute. I took 2 minutes, I think. Okay, so don't make more time. Yeah. Moving on to the question number 2. Consider the configuration shown in the figure, which is a portion of a large electrical network. Yes, there are 3 nodes available. See, these are the nodes. First, you can mark 1, 2, 3 like this. 1, 2, 3. For R is equal to 1 ohm, resistor value that is equal to 1 ohm. Okay. Then I1 is equal to 2 ampere. I1. Identify I1 is equal to 2 ampere. I4 is equal to minus 1 ampere. I5 is equal to minus 4 ampere. Which one of the following is correct? Data is insufficient to calculate I6. I6 equal to 10 amps. I6 equal to minus 5 amps. I6 is equal to 5 amps. Which could be the right answer? So it's a very simple question. You can able to manage it very fastly. Let us consider node 1. According to KCL, apply KCL. The incoming current, the sum of incoming current is equal to the total sum of outgoing current at a particular junction. Look at the junction 1 or node 1. Node or junction, both are same only. Look at node 1. So let me apply the incoming current. What is the incoming current? Let me write this I4. I4 plus I1 is equal to, let me write it as I1. I1 is equal to, what is outgoing current? It is equal to I2. It is very true. You can verify it. Okay. Now substitute the value. I1 is equal to how much? Minus 1. I4 is equal to how much? So I1 is equal to 2 and I4 is equal to minus 1. So I4 value is equal to minus 1. Minus 1 plus I1 is how much? 2. What is the answer? 1. So I have got the value of I2 is equal to how much? I2 is equal to 1 amps. Note down this. Consider where you can able to consider second node. You can see the second node. Okay, second node. Look at the second node. So what about the incoming current and what about the outgoing current? I2 and I5 are the incoming current. So sum of incoming current I2 plus I5 is equal to, what is outgoing current? It is I3. Do understand? Apply the KCL. So how much it is? 1 plus I5 is equal to minus 4, no? Yeah, it is absolutely minus 3 amps. I3 is equal to minus 3 amps. Note down separately. Okay, I3 is equal to how much? I3 is equal to minus 3 ampere. Now moving on to the third node. Look at the third node or junction. You can call it as junction as well. So incoming current I3 plus I6. I3 plus I6, that is equal to I1. I1. So I need to compute the value of I6. I6 equal to I1 minus I3. I1 minus I3. So substitute accordingly. I1 and I3 we already calculated. So 2. What is I3? I3 means minus 3, right? Minus of minus 3. So what is minus of minus 3? It is plus only. 2 plus 3. So therefore I6 is equal to how much? 5 ampere. I think you are agreeing with me. So it is having the definite answer. So better choose option D. Option D is the correct answer. Hope you are answering it properly and you can able to find out the right answer. Please make out the steps very fastly. If possible, compute the answers, everything in your mind itself. Save the time and you can go ahead with the different answers and you can crack the exam very fastly. And accuracy also matters a lot. So I'm explaining, so I'll be taking step by step, I'll be taking a little bit of time. So whenever you are writing the examination, don't take this much of time. You have to reduce the time. Okay, try to solve it very fastly. Hope you're understanding and moving on to the third question. A star network has a resistance of 10 ohm each in 2 of its arm, correct. While the third arm has resistance of 11 ohm in the equivalent D network. The D or delta network. The lowest value in ohm among these three resistance is. This problem is related to the star delta conversion. Okay, let us work out. Okay, read out the question once again. A star network. Star network. First of all, you know what is a star point. Okay, star point, star connection. Please recall. So 2 amps, the value of 2 amps is equal to how much? 10, right? See, like this you have to mark. So 10 now. Okay, this will be also 10 now. And third one, let me call it as 11 ohm. I have written according to the question only. I haven't added any other extra thing. So it's basically star delta conversion. No? So problem is related to star delta conversion or star delta transformation. Here, I have to frame like this. Yes. Hope you're understanding. Okay. Let me call it as X. This will be Y. Sorry, anything you can call, no issues. Let me call it as Y, X, Y, Z sequentially. Let me mark it as sequential manner. So let me calculate the value of X, Y, and Z respectively. So apply the star delta conversion or star delta transformation. So let me calculate the value of X. So how to calculate? So 10 into 10, then 10 into 11, then 11 into 10 divided by 11. So recall the formula. As I already told you to recall the formula. Okay, at any point you have to recall, which is very important for gate examination or IES level examination. Okay, you can expect the twisted level questions as well. 11 into 10 whole divided by obviously the value of X need to be calculated now. So here it is 11. So please make it fastly. You will be getting 29.09, almost 29.09. Decimal point you can make. 2 decimals are sufficient. Then Y you have to calculate Y. So let us calculate Y. So 10 into 11, 10 into 11 plus 11 into 10 plus 10 into 10 divided by 10. If you calculate, you should get around 32 ohm. 32 ohm. Z I want to compute. Z is equal to 11 into 10 plus 10 into 10 plus 10 into 11 whole divided by how much it is? 10. So solve it fastly. You should get 32. Verify once. Same answer, 32. So the lowest value you know among the three resistance, X, Y, and Z are given in terms of resistance, which is the lowest value. So you can able to calculate now which is the lowest value. Obviously, this is your choice. 29.09 is the lowest value. Now check, is it available in the option? Probably it's available in the option. You have to verify because answer is important, as I told many times. Especially this kind of examination, answers are most important. You should take a good decision as well. So 29.09 is the lowest value of resistance. You just verify the objectives. Sorry, options. So let me take you the options. Yeah, 29.09. So I should choose which option, which could be the right answer for my concern. I need to choose. Obviously, I have to choose 29.09. That's the right answer. Okay. So try to solve it fastly, as I told many times. Yeah, thank you. Question number 4. A periodic variable x is shown in the figure. Okay. And the function with respect to time, function of time. X is a quantity and that is varying with respect to time. The root mean square value, or you can call RMS value of x. So how to calculate this? It's a very simple question. So what you have to do is, you need to calculate the RMS value, and you have to recall the formula also. Before recalling the formula, you have to define the what is the quant x of t. You have to define. So let us define x of t. X of t. Okay. So look at the graph. Please look at the graph. X of t you have to define first. So x of t is equal to, first let us see the interval. Total time period is equal to 0 to t, right? So that has been divided into t by 2 and t by 2. So let us look at the half cycle. So half cycle means starting from 0 less than or is equal to t, time period, no? T. Okay, now not time period, function t less than or is equal to t by 2. T by 2. And also the second half cycle starting from t by 2 less than or is equal to t less than or is equal to capital T. T is the time period. Capital T is the time period. Okay. Now, what is the value of this? You have to calculate the slope. What is the function? Function you have to calculate. So this will be slope. If you calculate, you will be getting 2 by t into t. That you will be getting. And but the second half cycle output will be 0 only. So I need to compute only the first half cycle. Then the result will be completed. So you can use the RMS value. So XRMS has to be calculated. XRMS equal to, please recall the formula which you have studied in the first year classes. So what total time period is 1 by t. Okay, integral 2 cycle. Let us consider 2 cycle if you want. 0 to t by 2. Okay, 0 to t by 2. So first one 2 by t the whole square dt with respect to time, right? Dt plus next let us consider t by 2 to t by 2 to t. This must be 0 only. 0 square into dt. So this you need to solve it fastly. You know how to do the integration. So I will not be wasting much more time. So you will be getting, finally you will be getting the answer I will be telling you. You have to put the upper limit and lower limit. Finally, you should get 0.408. 0.408. So try to solve this, because integration you must have studied already in the lower classes. Calculus portion, you have to recall the calculus portion and try to match the answer. Is it correct or not? Just verify and kindly put up your valuable comment in the comment box. Okay. If you are having any doubts, just inform me. I'll send the steps also. Not a problem. Yeah. We have completed fourth question. Let me move on to the last question. Question number 5. In the circuit shown in the figure, the value of capacitor C in millifarad needed to have the critically damped response I of t. Okay, how to solve this? Anyway, you can apply the KVL. You can apply. If you apply the KVL, that means V of t. Total voltage. Here voltage source is not there. Anyway, let us see V of t. That is equal to I of t into R plus. What about the current and the voltage across the inductor? That means L into di of t. Voltage across the inductor. V is equal to L di by dt. Correct, no? Plus, regarding the capacitor, 1 by C integral of I dt. I of t dt. Okay. Now you have to differentiate with respect. You have to solve further. You have to differentiate with respect to time. Okay, you have to solve. Anyway, the first term will be 0 only. LHS part is 0 because no voltage source is provided here. And finally, you have to make out the particular equation, and you should make a quadratic equation. You will be getting a second order equation, and try to calculate the roots of the second order equation. And one root you have to consider, and you will be able to get the one relation like R by 2L the whole square, that is equal to 1 by LC. This relation you have to reach finally. From this, you need to calculate the value of C. C will be equal to 4L divided by R square. 4L by R square. So substitute the value of L. Everything is given actually. Just go to the question. L is equal to 4 Henry. And also R is equal to 40 ohm. These are the value they have provided for you. Substitute over here. You will be getting how much? 10 to the power minus 2 farad you will be getting. 10 to the power minus 2 farad. In terms of farad you will be getting. But what is the question? The answer is in terms of millifarad. Okay, millifarad. So 10 to the power minus 2 means 10, what I can say? It is actually 10 millifarad. So obviously it is 10 millifarad. I should go ahead with the option B. Option B is the correct answer, 10 millifarad. Okay, so you have to reach the particular equation. It takes little bit of time. Somehow you have to manage it. Okay, these are the somewhat higher level questions which you can able to expect in the competitive examination, especially nowadays. Because the toughness index is also very much high as the competition increases. However, you can manage it, not a problem. Okay. In this session, I discussed most important questions from the network analysis and a few basic questions from basic electrical engineering. So please go through all questions individually. Try to solve by your own. I have given some hints to solve this. Okay. In the coming session, I'll be uploading similar kind of video that will be really helpful for you. Okay. If you are having any suggestions, if I want to do any extra topics or any additional topics, you can put up in the comment box. I would like to thank you for your kind cooperation, and I am expecting the same cooperation in the forthcoming days. Let me conclude. Thank you so much.